All right, hello everybody. How are you doing? I cannot see any of you because these lights are really bright. But welcome to Building Web APIs with ASP.NET Core. My name is Cecil Phillip, and as the slide says, I'm a cloud developer advocate in Microsoft. I live in Florida, but I'm actually from an island called Antigua, a really tiny, small island in the Caribbean. All that means is that I took a really long flight to get here. So what we want to talk about today is, well, as it says, like how we could build web APIs with ASP.NET Core. Most of the stuff I'm going to talk about is going to be available in ASP.NET Core 2.2, but we're going to talk about some of the features that are going to be inside of 3.0 as well. Now, quick show of hands, or maybe you guys could clap because I really can't see you. How many of you are using ASP.NET Core today? A few of you in the back? Oh, claps. Wow, that's amazing. Are most of you building APIs, or are you using things like Razor Pages or Blazor or anything like that? You can just shout it out. I can hear you. APIs? Okay, sure. All right, so let's just do a quick overview before we really dig into the weeds of it. So right now, the current version that we have available is 2.2.5. That was released like not too long ago, just a couple weeks ago. We do have version 2.1, which is our LTS version. That's our long-term support version. So essentially, that means that you should be able to use that for at least another 3 years or so, and it's going to get patch releases. It's going to get minor fixes and minor updates. It's not going to get any major feature releases. But for those of you that need like a stable version that's not going to move around too much and change very much, like that's going to be the version that you want to stick with. Another thing about 2.1 I wanted to highlight for you is that 2.1 is going to be supported indefinitely on .NET Framework, mainly because going forward, ASP.NET Core is only going to be running on .NET Core and in the future, .NET 5. How about most of you guys heard about the .NET 5 thing that we're going to do? Right, so .NET 5 is going to come out next year. We're essentially just unifying the framework. So it's not going to be, there's a .NET Core thing, and then there's a mono thing, and then there's a framework thing. It's all just going to be one .NET. So that should make it a lot easier for all of us. In terms of 3.0, right now we have Preview 5 available. I'm going to show you some interesting features that we have available in 3.0 Preview 5. And again, like I said before, 3.0 will only run on .NET Core, and it will run on .NET 5 whenever .NET 5 comes out, but it will not run on .NET Framework. All right, so let's kind of just dig into some of the features that we added for building web APIs inside of ASP.NET Core. Now, if you're familiar to building APIs with ASP.NET Core, you're familiar with controllers and you're familiar with the startup. But one of the things that's really important for us is to really try and add these features that are going to enable you to apply rich conventions to your applications. So a lot of folks, when they build APIs, they use things like Swagger or Swashbuckle to generate documentation and enable you to like test your APIs inside of the browser. Any of you all familiar with Swagger or Swashbuckle? A little bit? You using it in your APIs? Right. No, essentially what this tool does is it inspects our APIs and it generates like this documentation for us. So one of the things that we tried to do as a company was we needed to find a way that we could provide more metadata so those tools can create better documentation. So if you take a look here, what you're seeing is that a pretty standard definition of what an action method might look like inside of your API controller. So you can see here I have an HTTP delete attribute. It's accepting a parameter. I'm returning not found, or I'm returning no content, and essentially it's just deleting something from our database. Now, if you look at the top here, you notice I give some basic information like summary. It has a parameter name. Like all of these are things that Swashbuckle and NSWAG and some of these types of tools can look at to inspect and see, well, this is what our API is doing, and this is kind of how it behaves. But this is actually just very basic information. What if we could give it more information so it could generate more documentation for us? So here you can notice that I added some additional things here. So there's some additional attributes that you might notice. Right, we have the ability to let it know like what type of response types are we returning. We also have the ability to let us know from the top here, we can provide more information about some of the response codes and things of that nature. Also notice too, like I've changed my type and I'm no longer returning action result, but instead I'm returning a concrete type, which is action result of T. In this case, it's a to-do item. And action result of T is kind of interesting, right? Because it could cast itself from a action result, or it can actually cast itself from a type too. And I'll show you a little bit of what that looks like. Another interesting feature we added in 2.0 or 2.1, I believe, was the API controller attribute. Now, ASP.NET Core has always been like a framework that's been built on conventions. And so this attribute allows us to apply more conventions by default, so your APIs will kind of behave how you expect them to. So one of the things that the attribute controller does is it enforces attribute routing. So you can't use conventional routing at all. Like, you have to have attribute routing enabled for your API controllers, and that's enforced by applying this attribute. It also applies some default binding conventions that you might just expect. So for instance, if you're familiar with the from query string attribute or the from body attribute, these are some things that you usually have to annotate in front of your parameters so you'll know where exactly should I grab this data from. Well, once you apply this attribute, you won't have to do that anymore. It'll just automatically know where these types are going to come from. So when you think about complex types like objects and things like that, it'll automatically grab it from the body. And if you pass something like an ID or like any simple type, like, it'll just automatically pull it from the query string. Like, and these are some of the conventions that it'll do for you. Another thing it does that's really cool, it'll do automatic model validation. So remember, inside of your method, you might say, if model state is valid or is not valid, and then you'll execute some type of logic inside of there. So this will just run that for you. So you don't really have to do that anymore if you don't want to. It also applies problem details for error status codes. So problem details is actually an RFC that was released some time ago, and essentially just defines how do you return errors from an HTTP API. Right? And so now we've just kind of turned this on, and it's the default way that we return errors to you. And then the last thing that it does, which I think is really cool, is that it enables API analyzers. Now, API analyzers, if you're familiar with Roslyn and Roslyn analyzers, these are just analyzers specific for building APIs. So again, it just, more ways for us to enable a lot of default conventions in terms of how we build these APIs. Now, specifically about these analyzers, one of the things that we could do, if you remember that previous code snippet that I showed you, if you notice at the top it had like produces status code with a 211 and produces like a 404. Now imagine like if you had lots and lots of API methods. Like, I'm going to have to add these attributes to all of these methods, and it can become a little bit of a pain sometimes. Now, using this analyzer or being able to add these in here, we can enable code actions, and these code actions would just now start to automatically add some of these things inside of our APIs for us. So it just makes it a little bit easier for us to build APIs. And if you wanted to grab it, this is a NuGet package that you'll have to add. It's Microsoft ASP.NET Core MVC analyzers. And you'll see as soon as you install a package, it'll kind of just light up, and you'll start to see some of these fixes available inside of your code. Now, what I'm going to do is I'm going to swap over really quickly to Visual Studio Code. I want to start showing you a demo of what some of this stuff looks like. So I'm going to head over to Visual Studio Code. So let me know if this is too small, if I should make this bigger or not. So here I have a pretty straightforward API. So it has it has get method, it has get by ID method. I'm doing an update using JSON patch. If you guys are familiar with JSON patch, it's a really interesting way for you to just apply batch updates to a resource. And I have create, and I also have delete. Now, if I take a look really quickly at what my startup.cs file looks like, again, it's very straightforward. I'm adding a DB context, I'm adding MVC, and then if you scroll down to the bottom, you can see that I'm adding things like Swagger and things of that nature. Now, let's go ahead and run this and see what actually happens. So I am going to start debugging. And now, while that spins up, I'm going to head over to Postman, which should be open somewhere over here. Great. Now, if you've never used Postman before, this is just a tool that I use to test my APIs as I'm building them. And I just happen to have a collection here at the left side with like some of those methods that I already have defined with some pre-can carriers. So for instance, I could execute my get products, and that should come back in a second. Oh, that's not right. Internal server error. What's going on over here? Okay, I know what's wrong. I'll fix that later. It's always good when you do demos just before you go on stage and it works, and as soon as you come on stage, it stops working. So what I'm going to do is, there's this database here. I'm pretty sure this is what the problem is. I'm going to delete this, and I'm going to restart this really quickly. I'm going to start debugging. All right, great. So again, in a second, this is going to run my API. I'm going to head back over to Postman, and I am going to run this method. So there we go. Great. And now you can see I have some data here that's coming back from my API. Again, very straightforward, nothing too crazy. Now, what if I wanted to post a product, right? I want to add a product to this resource, right? So notice what I'm going to do is I'm going to specify some JSON data. I'm going to post it into my thing. Now, what you're seeing here is like, well, it's sending me back a bunch of errors, right? Like there's some problems here. So it's essentially it's saying it really doesn't know how exactly am I supposed to use this, right? So, but why is that happening? So let's head back over to our API, and I'm going to stop this really quickly. And if I head over to my post method, you can see here that I'm not actually specifying where that data is supposed to be coming from, right? Usually I'd have to do something like, I'd have to come in here and I'd have to say something like from body, right? Not from form, but like from body or something of that nature, right? But now instead, what I want to do is I want to apply some conventions using that API controller attribute that I talked to you about. So I am going to uncomment this. And now, like I was telling you before, it should just light up some of these additional features that I'm just expected to having. Also notice here how some of these methods are starting to have these little yellow squiggly lines underneath them. And this is happening because, again, I've just applied that API controller attribute, but now it's saying, well, you actually haven't told us how, what exactly your APIs are returning, right? Like we need a little bit more information so we can know exactly what's going on. So notice that after I do that code fix, notice that it's just added all those types for me automatically, right? And it just did that by inspecting that action method. So again, instead of me having to write some of that stuff for myself, I could just use those code fixes and it'll just apply that for me. Now, why would you want to do this? Well, you want to do this because when you generate your Swagger documents, now it'll have more metadata to know exactly the types of response codes and the types of objects that your APIs are returning. Now, that's fine and dandy. But like I told you before, like I don't have to go through each and every one of my methods to do that, right? I want to have some general convention that knows when my APIs or my action methods look a certain way, these are the general types of status codes and response types that I want to return. And so one of the things that we have is called API conventions, right? Now, API conventions, now this is exactly how you apply it here, and I'll zoom in really quickly so you guys can see that properly. On the assembly level, I want to apply a certain set of conventions to all of the APIs that are in my project, and these APIs have to be annotated with that API control attribute. So now, by default, all those attributes like produces and produces response type and things of that nature are just going to be applied to my API without me having to add those attributes manually. So if I scroll down, you can notice all those, some of those yellow squiggly lines are gone away, right? And the reason that happens is if we take a look at this, here, this is essentially what a API convention type looks like. It's just a method. Here, the method really has no body, but it's a static method. And then we could say, here, these are the types that it returns. This is the method name, right? So if I have something that begins with the word create, like these are the types that I expect to return. Or if I have something, a method with the name delete, like these are the response codes that I expect to return. Again, like it's doing all this stuff by convention without me having to do all this stuff for us. Now, this particular one just happens to be what's returned, what's included in ASP.NET Core by default. If you wanted to create your own, and that just so happens to be what I did, you can, using those same methods. So here, notice like I created my own that are inside of here, for instance, for like a get and delete, right? But if you see my get here, anything that begins with the word get, it's going to return a 200 or not found. Anything with delete is going to return a 204, right? But essentially, this is how you can apply some of these the conventions to your APIs. And this will just make your Swagger documentation a little bit richer. Right, and so that's some things about API conventions. Let's head over back to the slides and keep going. Now, another thing I want to talk to you about is OData. Have any of you ever heard about OData before? A few of you? Usually when I say OData, people are like, oh, dude, are you serious? Like, OData is so old. But I'll tell you, it's actually interesting. Like, we've seen a lot of uptake in the ask for OData, especially now that Blazor is becoming a thing. And a lot of folks looking for interesting ways that they could query their data from the client without having to change their APIs too much. So for people that aren't familiar with OData, essentially what it does is it allows me to apply a set of conventions and practices to my APIs that enable features like querying and paging and some of these types of things. But again, like I don't have to really think about rewriting my APIs too much. Now, again, OData is a little bit old, and that's okay. But you'll see that it's still supported by a lot of interesting companies. Like IBM supports it, Red Hat supports it in a few of its products, SAP, and obviously we use it in a lot of our products too. So if you ever heard about like Microsoft Graph, for instance, uses a lot of OData type conventions for like querying data. So with that being said, let me switch over and I'll show you a really quick demo and sample of how you can create a OData service. So I'm going to head back over to Visual Studio Code. And I have another project open, and this is a OData API. Now, this is not too different from what we've seen before. One of the things that I've done in here is inside of my configure services, if you look here, you can see that I have a services.add OData. Right? So this is the first thing we do. We're going to add OData services. And then the next thing that we're going to do is that we're going to map a data model. Right? So OData works in the concept of an entity data model. Entities essentially are like the resources of your application. So in this case, I actually have a products API. And so at the bottom, I just mapped my product type over to an entity data model that's being used by OData. And then once I create that mapping, all I have to do now is create my controller. And my controller doesn't look too different from what we've seen before. I have a few different attributes that are on top of here, and then we'll take a look at some of those. Like you can see, I have an enable query, and that's going to allow me to do some of the OData querying magic, and I'm going to show you what that looks like. I also have this one that says OData routes. Right? Now, some of the OData URI conventions are a little bit different, and so because of that, it has its own special attributes that you have to apply for it. But again, very similar to the previous API, like I can do things like partial updates. Instead of using JSON patch, I'm using Delta in this case. And then I could do posts and deletes and things of that nature. So let's go ahead and run this. And let's take a look and see what it's like to build a service with OData. All right, so now that should be up and running. All right, now I'm going to head back over to Postman in a second. All right, great. Now, what I have here is a separate collection. And now this is going to allow me to execute and run some OData queries. Now, again, nothing too crazy. It doesn't look too different from what we've seen before. But remember, OData, the whole purpose is really to give your client more control over the data that it's receiving. So for instance, let's say I had a mobile client, or maybe I had a rich application that's running in the browser and I'm calling it by a JavaScript. Now, my models here have a lot of different properties like name, quantity, prices, and things of that nature. What if I didn't want to get all these properties? I only wanted a subset of them. One of the things I could do is I could select what properties I want to have returned. So for instance, if I only wanted the name and the price, I could specify that in my URL parameter. And notice now I'm returning less information, right? I'm only getting the name or the price because that's the only piece of information that I really care about. And what's good about this is that as your APIs evolve, if you add additional methods or if you add additional parameters or properties to your types, like this doesn't affect your query here at all, right? Like you're still only pulling back the information that you wanted. And if you wanted to add something additional, like maybe I wanted to add the quantity, for instance, like I could do that and I can just pull back the piece of information that I want just using OData. Now, let's say I wanted to do something else, like paging or sorting or anything like that. Like I could do some of that just by altering the query that I have here in the top. And remember too, like all this is happening on the server, so you don't have to worry about if you're building a mobile app or anything like that. Like none of this query is happening on the client. It's all happening server side. So I might be able to do something like $ order by, and I want to say order by name or something like that. All right. Now I'm going to run this. Oh, well, that's not good, right? It says returning me an error. It says the query specified in the URI is not valid. Now, if I head back over to my service, one of the things I want to show you is that if we head back over to the startup class, I want you to see that here at the bottom, I want this thing to go away. Here at the bottom, the way that OData works is that you have to let it know the types of queries that you want it to allow to be run on it. All right, so by default, my client can't just run any query that it wants. Like we have to allow it to do so. So for instance, if I wanted to do an order by, I have to enable it by saying, well, I want it to be able to order by, right? And if I wanted it to do other things like filtering, for instance, I have to enable filtering. If I wanted to do counts, for instance, I have to enable counts and like doing tops and things of that nature, right? So here inside of my startup.cs, as I'm defining my entity data model and enabling my routes, I also define what are the queries that I want to have this client be able to do inside of my application. So I'm going to go ahead and start debugging this again really quickly. And after that's up and running, now I should be able to go back to Postman, and I want to be able to execute this query. And now you should see, hopefully all the A's are at the top, and now all of my data has been returned back to me in a sorted manner. Now let's inspect this a little bit more and see what other types of queries we can run. So let's say I wanted to get accounts, right? I want to start doing things like paging inside of my query. First thing I could do is I could say count is equal to true. So now what this will do is this will give me the count of all of the entities or all of the resources that are available from that particular URI. Then maybe I want to select. So then I want to say select name and price, right? And then after that, maybe I want to do a top. So top is pretty much going to say, I want you to grab so many things from this API, right? So now I'm going to do a top 10, right? So I want you to give me the count, I want you to select the name and the price, and I only want you to give me the top 10. Sorry, that's not supposed to be there. There we go. Now, I only want you to give me the top 10. So I'm going to run this query. Notice here at the bottom it's giving me the count. So I have 50 total resources inside of this database. Notice it's only giving me about 10 of them. Oh, that's not right. $ count true. Oh, I'm sorry. I got to put the $ in front of this. There we go. There we go. And there we go. That's better. Great. So as you can see, I only have my 10 resources that I asked for. I only have the name and the price. And then I can specify the count. So I know now I can do things like paging, I can do skips and like things of that nature. So again, just something really simple and really interesting that you could do with OData. All right, so let's keep moving forward. I'm going to stop this application. So that's OData. All right, now, one of the things that we've heard a lot from our customers in terms of like them building services and microservices and things of that nature is that on .NET Core, we really didn't have a good answer for RPC style communication, right? So if any of you have ever used WCF before, WCF is not something that we're bringing over to .NET Core. It's also not going to be in .NET 5 either. But we still needed a way for us to do it's like some really efficient, really lightweight, point-to-point style communications. RPC style communication. And so one of the things that we've done is that we've partnered with some of the folks at Google to bring their GRPC framework over into .NET Core and have it use some of the intrinsics like dependency injection and the hosting model that we have inside of ASP.NET Core. Now, if you're familiar with gRPC, again, it's a project that really just came out of Google, and it's something that they use internally for some of their microservice work that they're doing. So it's really good for doing very quick, very lightweight streaming of information. If you're doing anything that's very contract based, right? So REST, for instance, is very convention based. RPC styles are more contract based. Like I want to call a method and I want you to run it and just give me a result. I don't want to talk about URIs. I don't care about, content negotiation or any of that type of stuff. I just want to call a method and I just want you to return to me very quickly. And so these are some of the scenarios that gRPC is good for. Now, the way that you define a gRPC service is using a serialization format called protocol buffers. Now, protocol buffers are really cool because it allows you to define the types that are going back and forth over the wire, but you could also define the services too, right? So again, like you can define the contract of what exactly your RPC calls and methods look like. Protocol buffers are really cool because it's a very small, compact way of sending data back and forth, right? It's a binary serialization format, so that means that it's much smaller and faster than using JSON or XML or anything else that's been text-based. And also, too, because we can define everything inside of a contract, it makes it easier for us to generate clients, right? So once you define your protobuf, once you define your protobuf contract, you can generate a client that you could use to call your service, but you can actually start generating some stubbed out code for your services as well. Now let me show you really quickly what a protobuf message kind of looks like. So here at the bottom, you can see that I have a product. And notice I have ID, name, quantity, price, and they all have types, right? And so this is exactly how we define like a message, right? This is the type that I'm going to be passing back and forth over the wire. If you take a look at the top, you can see that I'm defining two methods, right? There's getProduct and addProduct, right? And now getProduct, if you notice, has a special type called getProductRequest, right? And then it returns a product list. And an addProduct takes a product and then there's a product response, right? So now inside of your protocol buffer file, essentially you have to define what does the message look like? What does my response types look like? And so what I'll do really quickly now is I'll switch over and we'll take a look at a really quick protocol buffer sample that I created. Sorry for the jumping around. All right, so let's take a look at this sample. So I have a sample here called GRPC Demo, and that is not the file. And what I have here is my protobuf file. So this is pretty much an extension of the file that you saw a little bit, the sample of. So notice at the top I start with declaring the syntax, like I'm using protocol buffer version 3, right? Products is the name of the package, and in our case, it's the namespace that we're going to be putting our stuff in. And then here are all the different methods I have. So I have getProduct, getProducts, addProduct, and delete. Now we saw product already. This is just a definition of the type that we're passing back and forth. One of the things you see here, I defined another message called product list. And essentially product list as well as just a list of products, right? But this is how you define the list, right? You have a type, and then you just put repeated in front of it, right? And then notice this is what I'm using inside of this method, inside of my getProducts, right? Now, notice here I have a getProductRequest that's empty. And so that's because in gRPC, you can't have a method call that doesn't have a parameter, right? You have to send some message over there. Right? And so even though I'm not actually sending any data, like this message essentially is the signal that's going to say, hey, I want you to run this particular method. And so that's why when I have this getProductRequest doesn't have anything inside of it. Right? And now this one that I'm using for getProduct by ID, again, and I'll put this up a little bit higher so you can see it. I'm just defining a message type But I'm going to say anytime I give you a ID, like I want you to run a particular method. Now, after I have this, what I need to do is go inside of my CS project file. And you can see here, this is a .NET Core 3 project. One of the things that I need to do is enable, I need to let my project know about this protocol buffer file, right? So notice I'm saying GRPC Service is equal to server. So I'm going to generate stub code that's going to be used on the server side. You can imagine if this was the client, it'll be the opposite, right? I'll be GRPC Services client. And now what will happen is that every time I build my application, it's just going to generate code that knows about what products are, what the product lists are, but it also will give me some stub code that I could use inside of my server. Now, if I took a look at the product service for you really quickly. So you can see here, I mentioned before, I have that using products. So that product's namespace, that came from that protocol buffer file that I showed you earlier. And then this product service base, this is also code that just got generated for us, right? I didn't write this, I don't have this anywhere inside of my application. But what we do have to do is, after we inherit it, we have to essentially like fill out the stubs, right? So if you notice, like I have all these override async methods that are inside of here. And then I have the product ID message, I have product request message. All those things that you saw me define inside of that protocol buffer file have just been generated for me. But now I just have to write the code to actually do the work. And if you kind of look through this, you'll see it's very similar to what we had in the other demo. It's really just like doing like a CRUD application inside of here. Now, if you want to take a look and see what the client looks like, I'll show you the CS project for that. Like I said before, the only difference here is that instead of server, this says client, right? But again, every time on build, it's just going to generate some code for me. And then now inside of my client, what I get is a channel, right? So a channel essentially is saying, hey, I want you to open this channel, and gRPC works over HTTP2, right? So again, we have the ability to open like these long-lived connections that go back and forth between client and server. So I open a channel, and then I pass that channel to my product service client. And then now I just have these methods: get product by ID, delete product, and so on. And all I need to do on this side is I just need to call the method, right? But all this code has just been generated for us. Now, what's really cool is that at any point in time, if I decided I wanted to update this, let's say I wanted to add another parameter or I wanted to add another message type, all I'd have to do is update my protocol buffer file, recompile my application on both sides, and now I'll just have that additional data. Again, so it makes it really easy for us to, just define this contract, and now our code will just be generated for us. So I'm going to run this for you, just so you could, believe me and know that it actually works. So I'm going to debug this. I'm going to run the gRPC demo. Great, and so this should be up and running. And now I am going to have a task here. I'm going to run this task, and I'm going to run the gRPC client. Right, so all this is doing is this is going to do just a .NET run inside of my thing. And now notice it's just pulled back all of this data. All right, let me head back to the slides really quickly. Great. So again, that's how we could create services using gRPC. So remember, gRPC, it requires HTTP2. So if you have HTTP1 services, it's not going to work very well. It's probably not going to work at all. In Kestrel on ASP.NET Core, we do support HTTP2. Support's going to be even better when we get to 3.0. But again, if you're using anything like IIS or something that doesn't support, like old versions of IIS that don't support HTTP2, you're not going to be able to use this. Now, in what cases might you want to use gRPC over something like REST or something else that's text-based? So remember, some of the main benefits are really, because it's using protocol buffers, we have a very small payload that's going back and forth over the wire. So if you're working in environments that have bandwidth restrictions, something that you need to be very low latency and somewhere that you have to be very concerned about the size of your message package, gRPC is really good for those types of scenarios. For scenarios where you want to have a very strict contract in terms of the data that's going back and forth over the wire, again, gRPC would be great for like those types of scenarios as well. And obviously too, there's the benefit of having client generation. We could generate code both on the server and the client. That would make it like a lot easier for us to get going with our services. All right, so another thing that's been really important in the .NET Core wave is our support for microservices. Even from the beginning, like we've tried our best to make sure that our services are performant. And then with each version of .NET Core, like we start to get a little smaller each and every single time. Now, if you're familiar with Docker, one of the things that we've done on that front is that we've made our .NET Core images much smaller than they used to be. Right, so if you're thinking about creating microservices with .NET Core, and I don't know, maybe you need to spin up a lot of different services, now like the requirements on memory and also just the amount of space that it takes up is so much less. But today, I want to talk to you about two very specific pieces of microservices, and that's service discovery and health checks. So service discovery aims to solve three main problems for us. So one is, where exactly are our services, right? Like what do I have available? What types of services do I have running inside of my environment? Location, like I said, like where are my services located? And then also, like, what's the status of these running services, right? Are they up? Or are they down? Are they available, right? Do I have health checks that are checking to see the status of how they're running? So one of the things that we added, and that's going to be coming with even more support in .NET Core 3, is the ability for us to do health checks. So the health checks API, again, is available right now in 2.2. And it has the ability for us to define a health endpoint, kind of like a status endpoint, right? I really love this feature because this is one of those things that I used to write all the time by myself, and now it's just in the box, and I'm glad it's there that I don't have to do it. But we have the ability to tell whether our service is it ready, is it healthy, is it unhealthy, or is it alive and ready to go, right? And we like to define the difference between liveliness and readiness. Right. Liveliness is kind of like, hey, the node is up, the server is up or the instance is up, but I'm actually not ready to receive traffic yet. Like, don't send me a request yet, but maybe I'm still booting up or I'm still establishing my connection to a dependency or a third-party service. And ready essentially is saying, okay, well, hey, I'm ready to go. You could start sending me traffic. We also have, we've partnered with this open source project called BeatPulse, and they offer tons of different health checks that you could use inside of your own applications. So let's take a look really quickly and see what some of these things look like. All right, so I'm going to head back over to Visual Studio Code, and if I can remember where I put it. So let's talk about service discovery really quickly. So inside of Visual Studio Code, inside of this API service that I have defined, I'm going to go to my startup.cs file. And so now inside of here, inside of the configure services section, you can see that I've added my health checks, right? And this is a package that we could just pull in, and it's a part of the package that we made available for you, available on GitHub. And I could say stuff like add health checks. And then this next one is saying, I want you to add a DB context health check. So in this case, I'm using a DB context to connect to my database. So this health check is saying, well, can I actually communicate with the database? Am I actually ready to retrieve data from there? And the next line actually defined a custom health check. This one is just doing something silly, it's just pinging Google. But you can do any type of work in here that you wanted to. Maybe you needed to ping a service that's like inside of your infrastructure or something external to the cloud. Maybe there's like a third-party API that you depend on. You could do like some tasks in here just to make sure that those things are still up and they're running. And then the last thing you need to do to enable health checks is, well, just say use health checks, right? I notice I'm defining my /health endpoint. Another thing that you see I have here at the bottom, there's this use discovery client. So I talked to you about health checks a little while ago. Now this discovery, use discovery client, this method is actually coming from a third-party service and it's called Steel Toe. Has any of you ever heard about Steel Toe? Yeah? No? Okay. So Steel Toe, I'll go to this really quickly. SteelToe.io comes from Pivotal. Pivotal does things like RabbitMQ and Spring Boot and like some of these types of things. And essentially, they have this framework built for .NET Core that allow you to do things like service discovery, centralized configuration, and some of these types of things. So I pulled in their package because I wanted to enable service discovery, right? I wanted to be able to say, hey, as I'm spinning up these services, I want you to register with something that will allow me to know what's my location, what's available, and what's the status of that running service. Now, for my service discovery, I actually need a registry. Like, I need a thing that I'm going to register with to say, well, this is the source of information, right? Like, this is my service registry. And this is the thing that's going to check my health and let my other parts of my infrastructure know what's available. And so for that, I'm using another service called Console. Right? And Console comes from a company called HashiCorp, console.io. And this is also a free and open source project. And again, it's a really small binary essentially, and it just allows you to say, hey, these are the services that I have available. So what I'm going to do is I'm going to run console. I'm actually going to run console in a Docker container. All right, so I have a task that's going to set up and run console. Right? Boom. So console's up and running. So now it's just on my machine and it's listening for things to register with it. Right? And so notice that was up pretty quickly. And now I'm going to start my service. Great. So now what I'm expecting to happen is as my service starts up, if you kind of look and see what's happening here inside of that startup.cs file, right? Like, I'm going to set up my health check endpoint. I'm going to register NVC and do all the things that I'm used to doing. And then when my application is done, then I'm going to say, hey, I want you to register yourself with use the discovery client. I want you to register yourself with the service registry. So let's see what that looks like really quickly. So console actually runs, I have this mapped to port 8500. And so these are the services that I have available. And here's my products API. And notice here, it's doing my health checks for me, right? It's checking if the node is up, and it's also doing what's called service checks. So the node checks are just, can I reach the machine? Like, is the machine available, right? And then the service checks are more application checks. These are, is my database up? Can I ping Google? Like those things that you saw me define inside of that message. Now I could drill down a little bit more, and you can see that this is saying it's healthy, right? So now that means that if I go to console and I say, hey, what are all the services that know about products? Give me the healthy ones. It'll give me back this one, right? Because it's in the registry, and then it'll be able to say, well, this one's good and this one's not good. Now, one of the things I like about the BeatPulse API, as I go back over to here, is that they add a lot of different ways that we can extend this. So if you notice, when I was in console, all it said was healthy, but maybe you might have a service or an appliance that needs to have more information. So one of the things that the BeatPulse guys do is they allow us to enable this thing called a response writer. And now, instead of just returning a string which says healthy or unhealthy, it'll give me a little bit more information. This is actually going to return a JSON payload, which is going to tell us a little bit more about what's happening inside of the app. So I'm going to go ahead and run this really quickly. All right, so again, I just enabled that response writer. So now instead of just saying healthy, now I'm expecting to see a little bit more information in there. So I head back over to console, and I am going to refresh this really quickly. And now I'm going to go to this one. So notice the status healthy, but it also gives me more information, right? Like it's telling me about my DB context, right? The status of that is healthy. And then remember I had that ping service that's pinging Google, right? I can come over here and I can see that's healthy as well, right? So instead of just saying healthy, I could be like, which ones of these health checks are failing or which ones aren't failing, right? And we can get a little bit more detailed information about that. Now, it's when we talk about microservices, it's never really interesting when you only have one service. Like you usually want to have multiples of these, so we could do load balancing and round robin and round robin requests and things of that nature. So what I did here is I actually created a Docker Compose file. Is everybody familiar with Docker? Kind of? Yeah? All right, great. So now I have this Docker Compose file. And so now what this is going to do is it's going to stand up console, and then it's also going to stand up my product service, right? And so now all I'm going to say is Docker Compose up, and now it's just going to create this environment for me. And I'm going to be able to scale this up or down with one or more of these services. So I'm going to use the Docker extension that's available for Visual Studio Code. Right, I'm going to select my Docker file. And then now it's just going to go ahead and compose my application. It's going to run my Docker file. It's going to build some things. And then now I'm going to have my services up and running. 5, 4, 3, 2, 1. Maybe not. Port early allocated. That is because I didn't close the other one. Docker PSA. Sorry. I didn't close that other console that I had running. I need to stop this. Okay. So I need to say Docker, let's say stop. And actually, I think it's in one of these things, isn't it? There you go. I could just stop it here. Nice and easy. There we go. I'm going to shut down that client. Then I shut that one down before. Exit, exit, exit this. Great. Now let's try this again. I'm going to do Docker Compose up. I'm going to select that Docker file. It's going to go ahead and spin that up. So I'm going to have console listening on 8500, just like it was before. Now, what I want to do is I want to spin up more of these things, right? So instead of just composing one, I want to say let's launch like 10 of these. Run task console. That's not right. Docker run task launch console. Oh, that's not what I'm supposed to do. Sorry. I keep executing the wrong task. Docker run task, and I want to scale the product service. I'd say I want to add like 15 of these things. Right, so now it's going to go ahead, it's going to go start adding these things one at a time. But as that's happening, if you look here at console, I look at my products API, you notice like, well, some of these are red and some of these are green, right? Well, that's because these services are still coming up, right? Green in the node check means that, well, I can hit the machine, but here the service check says, well, I'm still coming up, I'm not ready yet. But if I had a client that was saying, hey, give me the good things, right? It'll probably give me that one that has the 2 greens at the bottom, right? But if I continue to refresh this, you'll notice after a while everything will be ready to go, right? And so again, that's how we could, essentially enable service discovery and health checks, so that now we could have a little bit more resiliency when we're building our microservices for .NET Core. Great. All right, let's head back to the slides really quickly. Let me not forget to close that for the next demo. Right. So that was health checks. Right. So now we have tons of other features that are going to be available in 3.0. Like I mentioned before, we're going to have better support for HTTP 2, particularly when it comes to doing things like, TLS and ALPN negotiation. Identity server integration for APIs is going to be coming. If you were in the previous session, I believe Ronald showed some of that stuff. That's going to be in the box for 3.0. Hopefully, we'll have client generation available for web APIs. So that'll be something like NSWAG looking at your Swagger documents and generating HTTP clients for you. And then we also have the new JSON APIs which are coming, which I think are really interesting. So today, like we very much depend on Newtonsoft.json now for most of our JSON work. So with the new APIs, they're going to be in the box, and they're going to be a little bit more performant. They're not going to allocate us less memory, which is going to be really important for us to continually, improve our performance. And obviously, we have endpoint routing too, is another cool feature that's coming. Now, everything that I showed you and talked about is going to be available at this link. This is called the URL list. This is just a place that, I keep a link of tons of links. So if you want to take a look at the code or look at the documentation, we also have videos of people building applications with gRPC and OData available at this link. So make sure you take a look here if you want to learn some more about it. With that, I want to say thank you. And if you have any more questions or anything that you want to know, I'll be walking around the conference throughout the rest of the week. Oh, you have a question? Yeah.
I have a question in the context of OData.
Yeah.
SAP is using something called annotations for OData.
Using annotations?
Yeah.
Okay.
Like the specific format to describe data and actions which cannot be used. Do you know about it?
Yeah, asking me about SAP annotations?
Just annotations in general as a technology.
So I think annotations, what you're talking about, might be something that's specific to SAP and what they're doing. So the OData support that's inside of ASP.NET Core, that's based on like the OData standard. So anything that they've built on top of that, that might be something that's more specific to them.
Okay, thank you.
Sure.